are the ACT most missed questions that you guys did in class. So I'm going to go ahead and go over these. If you have other questions about some of the other problems, I can post a video of someone else showing the whole test, but I thought I would just do these. So in triangle DEF, the length of side DE is the square root of 30 inches. The length of EF is 3 inches. If it can be determined, what is the length in inches of side DF? So on problems like this, can't emphasize enough, draw a picture. So we have a triangle. We're not really given any information as far as, if it's a right triangle. We're not told it is. You can't assume that it is. We've got, I'm going to label these. So if I call this D, this E, and this F, we're told side DE is the square root of 30 inches, and EF is 3 inches, and we need to know the side DF. We're not told anything about the angles, and if you don't know anything about the angles, you know 2 of the sides, we can't determine. There's not enough information, so that's the answer on that one. So this next question, we jump all the way to number 33. So if you are following along in your information from your work, Makia, an intern with the Parks and Recreation Department, is developing a proposal for the new trapezoidal Springdale Park. So we have this this picture here, and this actually went along with 32 through 34. 32 we seem to do okay on. So Makia's proposal includes installing a fence on the perimeter of the park. What is the perimeter in feet of the park? So we're looking at the perimeter. We don't care about anything that's inside that, just the perimeter. Now notice that we've got our scale model is in inches. So I'm going to actually draw a vertical line here. So then that tells me if this is 28 across here, then this portion of the base would also be 28. So if you do 40 minus, well, this whole side here is 40. The reason why we need this is because we've got to figure out this diagonal. So I know that this piece here would be 16. I know that this piece along here is 40 minus 28, so that would be 12. And then we're going to figure out this side. You can do the Pythagorean theorem on that. If you happen to notice, so you could do 12 squared plus 16 squared and then take the square root of that. Or if you notice that if you reduce these by 4, this is going to be a 3, this is going to be a 4, this is going to be a 5. It's a 3, 4, 5 triangle. 5 times 4 is 20. So this piece here would actually be 20 inches. Again, you could do this with the Pythagorean theorem. So then when you calculate that perimeter, remember the 12 is this piece, but we actually want to use the 40. So you're going to take 20 plus 28 plus 16 plus 40. And when you add those, you get 104 inches. And you might think, oh, look, there it is. It's C. That's the answer. And I'll be honest, when I was going through and doing this, my first, I actually circled that and then looked back at it again. On your scale drawing, 1 inch represents 1.5 feet. So we have to take 104 and multiply that by 1.5. And when you do that, you get 156. So that's actually the answer. So on this next set of problems, 35, 36, 37, we're all using this diagram. 35 and 36 dealt with a lot of this information with the parallel and perpendicular. However, 37 is actually a probability problem, and it just deals with this right here. So we're told that during the week the Smiths plan to roof the cabin. There's a 20% chance of rain each day. So Mr. and Mrs. Smith plan to roof the cabin on 2 consecutive days, assuming that the chance of rain is independent of the day. What is the probability that it will rain both days? Now, when 2 events are independent in probability, then you can actually multiply it together. So to find out the probability that it would rain both days, it would be 0.2 for the first day times 0.2 for the second day. So we get 0.04. So our answer was A. So again, knowing that if you have two events that are independent, then you can multiply those together. So a line through the origin and the point 10,4 is shown in the standard XY coordinate plane below. The acute angle between the line and the positive x-axis has measure theta. What is the value of tangent theta? So this is a trig question, and we haven't done trig yet this year. I know you did a little bit in your geometry class. So on this case, we're going to use this idea of SOHCAHTOA. So to figure out sine of an angle, and I'm just going to write this as sine, we're going to do opposite over hypotenuse, because it's going to be a right triangle. So if this is angle theta, then the opposite side would be opposite that angle that we're talking about. This side is called the adjacent side, next to, and the hypotenuse is always opposite the right angle. So sine, to find sine of an angle, you do opposite over hypotenuse. To find cosine of an angle, you do adjacent over hypotenuse. And to find the tangent of an angle, you're going to do opposite over adjacent. And so that's where this SOHCAHTOA comes from: opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So since we know, so I'm going to draw a line right here, we know this is the x, so this is 10, and we know the vertical, this distance would be 4. So relative to my angle theta, they're asking me the value of tangent theta, so here's theta. So I need to use the opposite, which would be 4, over the adjacent, which would be 10, and then I can just simplify that, and I get 2/5. So the answer is D. So this equation, it's an absolute value equation. Remember, with absolute value equations, we had two cases. So the first thing, and they even tell you that there's two solutions. So the first thing I'm going to do is subtract the 3 from both sides. So I get the absolute value of 2x minus 8 equals 2. And then if you remember what we did, we said that means 2x minus 8 equals 2, or 2x minus 8 equals the opposite, negative 2. So you might look at those options and say, well, I don't see any of those options. I know it can't be, you can rule out the ones that clearly are not it, so it's not that. They're not even the right numbers. Not this one. So we know, and it's not this one. So you can kind of rule those out. And then if you were to match these up, you'll notice that this one is a little different, because what they have done instead, they have said that 2x minus 8 is 2, or the opposite of 2x minus 8 is 2. Notice if I multiplied both sides by a -1, I would get this. So this is the other one, and if you match up which that one is, it's not G, because, so it's going to be this one down here, so we get K. All right. Okay, this next question, this is showing a frequency chart that shows the cumulative number of Ms. Hernandez's science students whose test scores fell within certain score ranges. All test scores are whole numbers. So by cumulative, what that means is you're just kind of, there was a total of 21 students in the class that took it. 12 of those students scored between a 65 and a 70. And then to get up to the next range, that's only one more person that was added to it. So when they ask the number of students with a test score in the interval 71 to 80, the 71 to 80 is going to be, take what was in the 65 to 70 and then we add 1. So we're adding 1 to that. So that's why there was only one person that scored in that 71 to 80. There would be, if you look, there's then we add 6 more students between 81 and 90, and then you add 2 more students between 91 and 100. So that's how you could use a cumulative frequency chart to actually get the different values. Okay, on number 42. The number of decibels D produced by an audio source can be modeled by the equation, and notice here we have a log equation where I is the sound intensity of the audio source and K is a constant. How many decibels are produced by an audio source whose sound intensity is 1,000 times the value of K? So they're telling you that the intensity, which is I, is 1,000 times the value of K. So what I'm going to do then is just take this and substitute it right here. So we get D equals 10 log, and here you're going to have 1,000 K over K, and the K's cancel. So you can use remember, you can use a calculator on this, but log of 1,000 is, if you're going to take log of 1,000, you just get 3. So, and you can do that if you just knew it. Otherwise, you can use your calculator and evaluate that if you need to. So we get 30 as an answer. Number 43, Mario plays basketball on a town league team. The table below gives Mario's scoring statistics for last season. How many points did Mario score playing basketball last season? So looking at this, we see that he attempted a 1-point free throw 80 times, but he was successful 75% of those times. So that's going to be 0.75 times, that would have been 80 points. So 75% of 80. Then we're going to add to that, he attempted 60 2-point field goals, and he made 90% of those, so 0.9. But remember that even though there's 60 attempts, 60 times 2 would be 120. That would be the number of points that he would get from those. And then for 3-point field goals, he made 25% of those, of these 60. But remember again, it's 60 attempts, which would be 60 times 3. So we want to know points. So this is the calculation that you would need to make. And if you do that, and of course you can use your calculator, which you can confirm this if you want to check on your calculator. I guess I could pull up my calculator so I could show you guys this. But you get 213. So that would be our correct answer for how many points he scored. All right, on number 45. So I think 44 we did okay on. 45, Toby wants to find the volume of a solid toy soldier. He fills a rectangular container 8 centimeters long, 6 centimeters wide, and 10 centimeters high. So, you know, it's all, if you want, you can draw a picture, and he fills that to a depth of 4 centimeters. Toby totally submerges the toy soldier in the water. The height of the water with the submerged toy soldier is 6.6 centimeters. Which of the following is closest to the volume in cubic centimeters of the toy soldier? So if you were to imagine you've got this container that you've got filled with water. It is 8 centimeters long, 6 centimeters wide, and 10 centimeters high, but only filled to a depth of 4 centimeters. So I'm just going to kind of, well, let's see. Okay, I'm doing a bad job on this now. So if I just think of 4 centimeters, so that would be the volume of the water if it was without the toy soldier in there. So we would have 4 times 6 times 8. So we get 192 centimeters cubed, and that's without the toy soldier. And then when you submerge the toy soldier, the height of the water is now going to go to 6.6. So that if you were to try, then you want to find the volume for that. So when you do that, if you multiply 8 times 6, because that's the base, the length times the width, times the height, which is 6.6, and if you do that, you get 316.8 cubic centimeters. That's the volume of the water with the toy soldier in the water, and then you're going to subtract those. And when you do subtract those and you find the closest one to it, you will get about 125 would be the closest. So on this one, we have a box in the shape of a cube has an interior side length of 18 inches. So we've got this box in the shape of a cube. Now the reason why they say it's the interior is because you're, well, that's not very good there. Is because you're putting that inside, and so there is thickness of the box, so that's why they do that. So we've got 18 inches, and it's cube, so we have this, and then we are going to use this to ship a right circular cylinder, which is something like this. Oh, I don't know why. Okay, that was not very good. That's all right. With a radius of 6 inches and a height of 12 inches. So the interior of the box not occupied by the cylinder is filled with packing material, and we have to come up with the cubic inches, so that's talking about volume, of the portion with packing material. So we need to know what, how to find the volume here. It's the volume of this cube is going to be 18 times 18 times 18, or 18 cubed. So we need to know how to find the volume of a right rectangular cylinder, which is the area of the base, which is pi r squared, times the height. So we end up with 36 pi times 12. Okay, and then we have to match the expression because we would be subtracting those. So we need to find 18 cubed minus something, so it's not these. And we want pi r squared h, so it is going to be this one. So we end up with j. So it was just the expression. I didn't, the 30, I did 36, but it was 6 squared. So knowing what that strategy is. All right, so this next one, a room has a rectangular floor that is 15 feet by 21 feet. What is the area of the floor in square yards? Very typical problem that people miss. Chances are you guys did this. 15 times 21. You get an answer of 315, and you think, oh, easy enough, right? There's 3 feet in a yard, so let's just divide by 3. So my answer must be 105. Doesn't work though. So here's what's going on. If we change this to yards first, so if we want to do 15 divided by 3 is 5. So changing that to yards, we get 5 yards times 21 feet divided by 3, you get 7 yards. And we know that we can multiply and get 35 square yards. So then the answer is B. So why doesn't this work? The reason why is if you multiply 15 times 21 and you get 315 square feet, and then let's use a unit conversion. You know that 1 yard is the same as 3 feet. And that's kind of where you got this idea to divide by 3. However, the units won't cancel. This is feet, this is square feet. So I would actually have to square this and square this. So, which means I square that 3. So I get 315 square feet. And then this was 1, because 1 squared is still 1 square yard. But the conversion for that, this makes it a 9 square feet. If you take 315 and divide by 9, then you get 35 and it works. So be really careful. You cannot, when you do unit conversions for square yards to square feet, you've got to square the number portion as well. So that is a typical ACT type question, and it's not hard to get the right answer, but you have to know how to make those conversions. So this type of function, when you look at the graph, this is called a step function or a greatest integer value function. But even without knowing the name of the type of function, you've got cab fares. And what typically will happen is you pay a certain rate, and then when it gets to the next mile amount, or sometimes they're even by quarter miles or something, then it jumps up to another fare. So it's not like a continuous line you end up with, or a continuous curve. You end up with these jumps depending on how many miles you are going to travel. So our question, when the fares of the two cab companies are compared, what is the cheaper fare for a 5-mile trip? So you're going to locate the 5 miles, which is right here. And if you take a look for this one, now notice the open circle, go right on past that. We need to go where it's a closed filled in circle. So ABC cabs is going to cost $12 for that fare. And for this one, if you go up again to this filled in circle, we get $9. So that is going to be the cheaper fare. So on this next problem, we've got a graph of a function consisting of 3 line segments, and we have them shown here with some coordinates listed for us. We are trying to find the area in square coordinate units of the region bounded by this graph, the positive y-axis, so that would be here, and the positive x-axis. So we're looking for this area under here. What I would do would be to kind of separate this into a few shapes that I'm familiar with. And we know that looking here, and then use the ordered pairs, I'm using the x values to go from a 3 to a 5 would be 2. So that means this piece right here would be 2. Notice the y value is 0, goes up to a height of 3. So this piece would be 3. So for my triangle region, we're going to do base times height divided by 2. So when we do that, we have 3 times 2 divided by 2. So then that gives us 3. So that's one of the regions. Then here I have a rectangle, and I'm going from a 2, 3 to a 3, 3. So that's a distance of 1 there, and we know this was already also a 3. So for my rectangular region, it's 1 times 3, which is 3. And then this, I have the shape of a trapezoid. So this side here is 4, and this piece here, because remember this point is 2, 3, so this is a 2, and this height was a 3. So remember, to find the area of a trapezoid, I add the 2 bases, and then I am going to multiply by the height, which is going to be this 2, and then divide by 2. So when I do that, I get 7. So then I'm going to have 7 plus 3 plus 3, which is 13 square units, and so that would be my answer. Okay, so for this next problem, this one kind of threw me for a loop, I'll have to admit, although it's very doable for you, but I kind of look back at this and think you almost could do this probably easier with some guessing and checking to come up with the right answer. But let me show you how to do this algebraically. The sum of 2 positive numbers is 151. So I'm just going to let my 2 numbers be x plus y equals 151. The lesser number is 19 more than the square root of the greater number. So I'm going to decide which one is which. I'm going to have x be the larger number and y be the smaller number. So then I have the lesser number, which I said was y, is 19 more than the square root of the greater number. So I get this. So now I have to solve this system of equations, and I'm going to use substitution to do that. So I'm going to take this expression and plug it in for y. So I get x plus the square root of x plus 19 equals 151. Then what I did next is I subtracted everything. I subtracted the 151, so I got x plus the square root of x minus 132 equals 0. So now what I did next, because at first I was doing something where I was moving the numbers over, I was squaring both sides, and it was turning into a mess. And then I thought, well, wait a minute, what if we do substitution? And if I let u equal the square root of x, remember this is like x to the 1/2 power. So if I let u be x to the 1/2 power, then u squared is just x. So then I end up with u squared plus u minus 132 equals 0. If you do a diamond problem, you're going to get, because you get 12, a positive 12 and a negative 11. Don't need a box because it's just a u squared, so we have u plus 12 times u minus 11 equals 0. Zero product property, u plus 12 is 0, so that means u equals negative 12, or u equals 11. So remember, it's not a u, it's a square root of x. So we have the square root of x equals negative 12, or the square root of x equals 11. This doesn't make sense because you can't have the square root equal a negative 12. So we get x, the square root of x is 11, which would indicate that x was 121. And if x is 121, 151 minus 121 means y equals 30. But the problem says, what is the value of the greater number minus the lesser number? So we need to do 121 minus 30. And when we do, we get 91. And that's the answer. So that one was obviously a lot harder than some of the other problems that we've looked at, but you can expect that on the ACT. It's no wonder that these last 15 problems of the test were highly missed by all of you, because this is where the harder stuff is. So from here on, they're going to get a little tough. Okay, this next one gives us a list of numbers, but notice 2 of the numbers are missing, and we're told that this list has a median of 25. What you need to remember is the median is the middle number when the numbers are placed in order, and it appears that the numbers are in order, in descending order. They tell you the mode of the list of numbers is 15, so you need to remember that the mode is the one that occurs the most, which tells me that x or y or both must be 15. Okay, so actually, let me change that. If they're in order, then let's say y or both, or y or both x and y. It can't be x alone. But we also are told, since we know that there are 6 numbers here, the middle number has to occur between these 2. So how you find the median, since there's an even number of numbers in the list, is you would have to add those and divide by 2. So we're told that 30 plus x, and then if we divide that by 2, that has to equal 25. So 30 plus x has to equal 50. So now we know that x has to be 20. Well, then that means that y has to be 15, because that's the mode. So there has to be more than one of those. So now we know the list of numbers. So we can do 41 plus 35 plus 30, and x was 20, and y was 15, and we had another 15. So we're going to add those all up and divide by how many there are. There were 6 in the list, and we get our mean. So our mean is 26, so the answer is C. So that one actually required that you know what a mode is, that you know what a median is, and you know what a mean is, so you get a lot of mileage out of one problem, and that's what the ACT does. Okay, another kind of tough one. You're given the following system of equations: y equals x squared, rx plus sy equals t, where rs and t are integers. For which of the following will there be more than one xy solution with real number coordinates for the system? Now, first of all, notice that this first one is a parabola, the second one is a line. So you're looking at a parabola and a line. You want to know where we're going to have more than one solution. We're not going to do it by graphing or anything like that, though. So we have y equals x squared, and then this other equation also has a y in it. So I'm going to start by substituting. In place of the y, I'm going to put an x squared. So when we do that, we get rx plus s times x squared equals t. So remember, r, s, and t are integers, so they're constants. My variable is the x. So I've got a quadratic equation, so I'm going to put this in standard quadratic equation form. So we have sx squared plus rx. I'm going to subtract the t equals 0. So recall from the quadratic formula, because actually this right here should remind you of the discriminant, where we have, and you can't help but sing it, x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So in our problem, a is s, b is r, and c is negative t, because we have that, it's negative right here. So when you plug that in, now it's only the discriminant that tells us how many solutions we have, because if this is less than 0, then we have non-real solutions and we need 2 real solutions. If this equals 0, then we ended up with just 1 solution, so we don't want that. So we want this b squared minus 4ac to be greater than 0, but we need to plug in our values here. So instead of a b squared, we have r squared minus 4 times s times a negative t. We want that to be greater than 0, which gives me r squared plus 4st greater than 0. So that's the condition. So the answer would be F, and that would give us 2 real, or more, we would have 2 real solutions. So on the next problem, the third and fourth terms of an arithmetic sequence are 13 and 18 respectively. What is the 50th term of the sequence? We haven't done sequences or series yet. That's a topic we are still going to do. But if it's an arithmetic sequence, what that tells you, and I'm going to make little dashes here, our first number, our first term, our second term, our third term, our fourth term, and then we would continue on with additional terms. We have to get up to 50. So the third term is 13, so I'm going to fill a 13 in here. The next term is 18. What you would need to know is arithmetic sequences are just, they're linear in format. So it's going to be like a line. So notice that this goes up by 5. So I add 5 to get from the 13 to the 18. So if I want to go backwards, I'm going to subtract 5 from the 13. And when I do that, I get 8. So the second term would have been an 8, which means the first term would have been a 3. So I'm starting out with a 3. This is kind of like my y-intercept for a linear function. So that's my first initial term. So, and then I want to find the 50th term. So I'm starting with a 3. I'm going up by 5, by increments of 5 each time, and I have to have 49 increments, because remember, this was the first term. So this was the second term. I have to do that, adding a multiple of 5, 49 times to get to my 50th term value. So when I do that, you get 248. And that would be our answer. So the answer is A. So remember, if you see arithmetic sequence, you want to think of that like a linear function and do that. If by chance you should see something about a geometric sequence, then that is a common ratio. Instead, it behaves like an exponential function, and you are multiplying by what's called a common ratio instead of adding. So that would be a different kind of sequence, and it's similar to an exponential function, whereas an arithmetic sequence is similar to a linear function. So this next problem is just one of those ones, I mean, I can show you, but we haven't done this yet. So this is dealing with trigonometry graphs, functions, trig identity, dealing in radians instead of angles, which we just haven't done yet. This is a topic that will still be coming. But I'll let you know that there in trig there is an identity that says that sine squared x plus cosine squared x equals 1. And we're going to talk later about why that is, but this is just something that is true. So when you look at this and you see, okay, sine squared x plus cosine squared x equals 1, then that's like saying y equals 1, which is why the answer to this question is H. So knowing this identity, the problem's actually very simple, but without knowing that identity, it'd be kind of difficult. What you can do, if you are going to try and use your calculator just to see something or to graph, then you need to know that if you're dealing in radians, if you see pi when it's talking about the angles, then if you hit the mode key, make sure that it says radians and not degrees. Then if you were to actually calculate, now in order to do sine, this is sine squared x, so that would be like sine x squared. You'd have to type it in like that. So pick a number, and again, this is kind of putting you at a disadvantage because you don't even know what's in between negative pi over 2 and pi over 2. But hopefully you know that 0 is. So try doing, you'd have to put a parenthesis and then sine of 0, and then close that, and then put a squared. Okay, so that's my sine of 0 squared, plus, and now let's do the same thing for cosine. So I would type this, cosine 0, close that, squared, and then hit enter, and you get 1. Because no matter what you plug in for x, you're going to get 1, because that's an identity, no matter the value of x. So, you could try something like that with your calculator, and hopefully if you see one of those like that, maybe stumble upon the right answer. Again, another question that we just haven't got to yet. So when you are looking at the period of a function, so when you are looking at trig graphs, and I'm going to actually do sine, which is the reciprocal function, sine x is equal to 1 over cosecant x. So, or I could say cosecant x equals 1 over sine x. They're reciprocal functions. So if I were to just show you the graph of sine x, and then I'm going to, when I actually graph this, I'm going to set my window from, and I'm in radians, from negative 2 pi to 2 pi. And actually, I'm gonna go, if you hit zoom and number 7, notice it says trig. I'm gonna do that. It sets it from negative 2 pi to 2 pi. A sine curve looks like this. What's meant by period is how far does it go before it starts to repeat. So this is negative 2 pi and this is 0, and then notice it repeats again. So every 2 pi it repeats. So we would say the period is 2 pi. And it actually is also true for cosine, it's also true for cosecant, it's also true for secant. It's not true for tangent or cotangent, but those are the period for those is half of that. It's pi. So what you do though for this one, because it's not just an x, it's a 4x. So to get the period, you're going to take 2 pi, which is the period of what it would have been, like the parent graph, and divide by whatever number is here. And so then we end up with pi over 2. And so that would be the period for this function. Again, probably not something you're going to get right if you have one of these on the ACT, unless it's just something you remember, period is 2 pi. And then, if you should have anything like this on there. So at the school carnival, Mike will play a game in which he will toss a penny, a nickel, and a dime at the same time. He will be awarded 3 points for each coin that lands with heads face up. Let the random variable x represent the total number of points awarded on any toss of the coins. What is the expected value of x? Well, if you're in AP Stats, you should know exactly how to do this one. We would start off with, let's think about what possibilities that he could get. So on the first coin toss, let's say that this is the penny. He could get heads or he could get tails. And then on the nickel, he could get heads on the penny, heads on the nickel, or heads on the penny, tails on the nickel, or tails on the penny, heads on the nickel, or tails on the penny, tails on the nickel. And then we've got the dime. So we could get heads, heads, and then heads, or heads, heads, and tails. And you kind of see how this can go. So I've got all these outcomes. So this one is heads, heads, heads. This would be heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, oops. Tails, tails, heads. Tails, tails, tails. So he is getting 3 points for each coin that lands with heads face up. So if you look, if we make a chart, I'm going to let X represent the number of the coins that are heads up. So maybe he doesn't get any of them. Maybe it's tails, tails, tails. Or maybe he gets 1 with heads up, or maybe 2 with heads up, or 3 with heads up. So the probability of that happening, there's only one way. If he gets 0 heads, that means he's got all 3 tails. And notice there's 8 outcomes. So 1 out of 8 is the chance of getting none, no heads. And so you can change that if you want to. If you change that to a decimal, you get 0.125. Exactly 1 heads would be 1, 2. 2 possibilities. So 2 out of 8, which is 1/4 or 0.25. Or we could get 2 heads. So there's 1, 2, 3. Wait, I missed one of the 2 tails, didn't I? 1, 2, 3. There were 3 of those. Sorry about that. So we have 3 out of 8, which is 0.375. Also 3 out of 8 for this one, 0.375. And then for this, we have 1 out of 8 if you got all 3, so 0.125. Now you'll notice that these probabilities add up to 1 because all probabilities, if you have of all the sample space, has to add up to 1. So in order to get what we would expect, the expected value, you actually multiply the 0 times 0.125, then you would multiply 1 times 0.375. Let me show you over here. Obviously, I'm not going to do 0 times 0.125 because that's just going to be 0. So 1 times 0.375 plus 2 times 0.375 plus 3 times 0.125. And when I do that, I get 1.5, and I might look at that and go, oh, look, G's the answer. This is the number of heads up. He gets 3 points for each coin that lands heads up. So we actually have to take that and multiply by 3 to change this to points. So it's 4.5. So we get 9 halves. And I'll just tell you, the first time I went through this, I missed this problem because I chose G because I got done with the expected value. I saw the answer and thought, oh, great, that's good to go. Be really careful when you read these problems because a lot of times there's that second part to it that you have to pay attention to. So another thing we haven't done yet is matrices, and actually we're not even doing those this year. For what positive real value of k, if any, is the determinant of the matrix, and then they give you this matrix equal to k. I think we did a little bit on matrices when we did systems of linear equations. Now here's why it doesn't matter. They tell you how to calculate the determinant of the determinant of the matrix. So they give you that. So that helps. So then if you use that, then that means we're looking for, kind of follow the model, A times D minus B times C, which means you're going to do K times K, which is K squared, minus 3 times 4, which is 12, and we want it to be equal to K. So I've got a quadratic equation. So I'm going to set it up in the right format. K squared minus K minus 12 equals 0. You can actually factor this. So we get K, that's going to make this a minus 4 and a plus 3. So then K minus 4 is 0, which gives me K equals 4. Or K plus 3 equals 0, which gives me K equals negative 3. But they say I need a positive number. So there it is. And there's the answer. So even without knowing about matrices, because they told you this, and you could just apply that formula and come up with that answer. So this is one we have done. Given a positive integer n such that I to the n equals 1, which of the following statements about n must be true? And they tell you, they remind you that I squared equals negative 1. Remember, there was a pattern. So if we had I to the first, of course, was just I. And then we had I squared, which was negative 1. And we had I cubed, which was negative 1 times I, which is negative I. We had I to the fourth, which is I squared times I squared, which is 1. So I kind of went through that fast. We've done that before. If you keep going, like I to the fifth, you're going to go back up to here again. So you have this pattern, I, negative 1, negative I, 1. I, -1, I, 1. And it goes in patterns of 4s. So we want to know when I to the n, when it equals, what has to be true about n if we get 1 here for an answer. So that means, like think about the values that would give you 1, like I to the 8th is 1. I to the 12th is 1. I to the 16th is 1, because it's every fourth one. So that's going to be then when n, if n is divided by 4, like 8 divided by 4, gives me, I have a remainder of 0, because it goes 2 times with no remainder. So in order to get 1 for an answer, this would have to be true. Okay, another one we haven't done yet. Let me just give you something that you could possibly reason through with. We're comparing, or we have this idea of something to do with sine theta. I know they have the absolute value of sine theta greater than or equal to 1. So I want to talk a little bit about sine. Remember when I was showing you on a previous problem, and if this was theta, then this is opposite, this is hypotenuse, this is adjacent. Sine theta would be its opposite over hypotenuse. Well, if you think about this, the hypotenuse is always the longest side of the triangle, always. So if you do a ratio of opposite over hypotenuse, then you're always going to have something that is less than 1. When you're dealing with a triangle, it's always going to be the case. Now, if you were to evaluate, remember my calculator, pi over 2 radians is the same as 90 degrees. So again, something we're going to be doing soon. So if you were to evaluate, remember I'm still in radians, if you were to evaluate sine of pi divided by 2, you'll see that you get 1. And so since this is the absolute value, if you were to do sine of negative pi divided by 2, and the reason I'm doing that is because of this negative pi over 2 right over here, you get -1, but you're taking the absolute value of that. So all other values, for every other angle, it's always going to be less than 1. So because of this idea of the ratios of the sides of the triangle, which is why A is the answer. So you only get those 2 particular values of theta that will make this true, because all the other values of theta, you're going to get a ratio that's less than 1. So again, we haven't really done that, but there's a little bit of information that maybe could help you. And finally, what you've all been waiting for, the last one. And we could do this one. Ray PK bisects angle LPM. So we have this angle LPM that's being bisected, so I would recommend draw a picture. So I'm going to let this be LPM, and I'm told that ray PK bisects that, so that's going to split it in half, which I did not do a very good job of that, but that's okay. Which means that this angle is congruent to this angle here, because it's a bisector. All right, so we've got angle LPM is 11x degrees. So that's this whole thing is 11x degrees. And then we are told that the measure of LPK, so that's this angle, is 4x plus 18. And we want to find the measure of KPM. So we are looking for this. All right, so we know that if we have, since this is a bisector, now don't go by my length here, remember it's the angle, but I just marked it way out here. So we know that if this is 4x plus 18, then this is also 4x plus 18 because it was a bisector, so it split it in half. So then if I have 2 of those, so if I have 2 of these, 4x plus 18, then I have to get 1 of these, the 11x. So that has to be equivalent. So I get 8x plus 36 equals 11x. and which means I have 36 equals 3x. So x equals 12 degrees. But we want to know the measure of kpm, which is the same as LPK. So we have 4 times 12 plus 18. So 48 plus 18 is 66 degrees. And that's our answer. And we are done.